Welcome back to All This Math. This is Professor Parker, and we're solving a trigonometric equation again. All right, now look at this one. This looks a little different. I don't think I've done any videos where I've solved a trigonometric equation that look quite like this. This is it looks intimidating, but it's not really that bad, all right? We got to think about how we solved algebraic equations before you got to trigonometry or before you got to PreCopolis, right? Notice what we have here. We have 3 times the tangent of theta cubed. Tangent of theta cubed to the third power, not to the second power, to the third power, is equal to tangent of theta. So what are we trying to solve for? We're trying to solve for theta. But the issue is you see theta in more than one place, right? Theta is on the left side of the equation and theta is also on the right side of the equation. You also have tangent in more than one place. So what you should do is this, right? When you encounter a situation like this, you move all your tangents to one side of the equation, or basically put the equation in standard form, right? So this is what it's going to look like. 3 tangent of theta cubed minus tangent of theta is equal to 0. So now we got 3 tangent of theta cubed minus tangent of theta is equal to 0. Why is it minus tangent of theta? Because I subtracted it from the right side and I subtracted on the left side. Or you can think about it as transposing. Think about it as me transposing tangent theta, basically picking it up and moving it over to the other side, so to be minus. Now, why am I doing that though? Why, right? When we're doing math, we need to think about why we do what we do. Because then that'll help you to inform you as to what you should do in the next problem you see that looks like this. You do this so that you can have all your tangents on one side so you can factor out one of the tangents so you'll have tangent in one place, right? Or even if you don't end up with tangent in one place, because actually in this problem, you're still going to end up with tangent in 2 different places, but you want to factor so you can create separate equations, because sometimes you're going to have multiple equations, right? Because this is a cubic equation to the third power. But if you simplify it, what's going to happen is you're going to end up with something to the first power and something to the second power. And then you can solve each of those individual equations, all right? And then you'll get your solutions that way. So also know this equation is going to have a bunch of solutions. So we got 3 tangent cubed of theta minus tangent of theta. And I'm looking for a greatest common factor. So think back to Algebra 1 when you had to find the greatest common factor of polynomial expressions. We're doing the same thing here. I see a tangent here and a tangent here. Or I should say a tangent theta here and a tangent theta here. So my greatest common factor is tangent theta. Tangent theta, that's my greatest common factor. So I'm going to write the greatest common factor, which is tangent theta. And then I'm going to write parentheses and I'm going to write an equal sign and 0. Now the question is, what goes inside the parentheses? What goes inside the parentheses? What goes inside the parentheses is the quotient I get when I divide each of these original terms by tangent theta. So now I got 3 tangent cubed theta divided by tangent theta, which is equal to 3 tangent squared theta. 3 tangent squared of theta. Now, why is it 3 tangent squared of theta? Because 3 divided by this invisible 1 up front is just 3. Tangent to the third power divided by tangent to the first power. Remember your exponent rules. What happens when you divide with exponents? You subtract the exponents. So if the numerator has an exponent of 3 and the denominator has an exponent of 1, you would do 3 minus 1. 3 minus 1 equals 2. So that's tangent squared of theta. That's why we have 3 tangent squared of theta. Then I'm going to have minus 1. Now, where did the minus 1 come from? Tangent theta divided by tangent theta. But that's negative tangent theta divided by positive tangent theta. You divided tangent by tangent. It's the same thing. It's just like dividing x by x or dividing 2 by 2. It gives you 1, and it's negative, so it's minus 1. So here, this is how we're going to have our 2 equations set up. One factor gives you 1 equation. The other factor gives you another equation. One factor, 1 equation. Another factor, another equation. So think about it like this. That's 1 equation, that's 2 equations. So each factor is going to be equal to 0. So I'm going to have tangent theta is equal to 0, and I'm going to have 3 tangent squared of theta minus 1 is equal to 0. These are my 2 equations. Now I got two separate equations. We started out with one equation, but now we break them down into two separate equations, and now we can solve for theta. So now I want to know, okay, if I do inverse tangent, I want to know what angle, because we're looking for theta. Theta represents an angle, some angle on a unit circle, right? Well, I want to know what angle has a tangent of 0. What angle has a tangent of 0? I'm going to go right to my trigonometry table. Download one online. Download one. Look up trigonometry ratios table. Just look it up, right? It might be one of your textbooks. You might not even need to go online. What angle has a tangent of 0? So go to tangent and then go across to 0, and I see 0, pi, and 2 pi. 0, pi, and 2 pi. So theta is equal to 0, and we're dealing with radians. Pi and 2 pi. And you know what? I forgot something. I keep forgetting this. This is the interval from 0 to 2 pi. So all the way around the unit circle. All right? And I guess we could say that 0 and 2 pi are really the same thing. Basically, I need to think more about that. Like whether 0 and 2 pi are considered the same. So if we need to include both, I'm not really sure. I would need to think more about that and get back to you. But those are the solutions for tangent theta equals 0. Over here, now we got to solve this. 3 tangent squared of theta minus 1 is equal to 0. So the first thing I would do is I would get rid of the -1. After I get rid of the -1, I would get rid of the 3. After I get rid of the 3, I would get rid of the exponent. After I get rid of the exponent, then I would get rid of tangent, leaving me with theta by itself. So what I'm going to do is I'm going to do +1 on the left, +1 on the right. They cancel out. Then I got 3 tangent squared of theta is equal to 1. And then I'm going to get rid of the 3, divide by 3 on the left, divide by 3 on the right. Is equal to 1/3, divide by 3 on the left, divide by 3 on the right. Tangent squared of theta is equal to 1/3. Now I want to get rid of the exponent too. So I'm going to do the square root of tangent squared of theta is equal to now plus or minus, because I want the positive and the negative value, because I'm taking the square root, right? I don't want to disregard the negative values since I'm taking the square root. So tangent squared of theta is equal to plus or minus the square root of 1/3. The square root symbol and the exponent 2 cancel each other out, leaving us with just tangent theta, which is what we wanted to happen. And then we got plus or minus. Now, square root of 1/3, we can think of that as the square root of 1 over the square root of 3. 1 is a perfect square, so the square root of 1 is just 1. That's going to be 1 over the square root of 3. Now, tangent theta equals plus or minus 1 over the square root of 3. So now I'm looking for the angle, because theta represents the angle. The angle that has the tangent of 1 over the square root of 3 or -1 over the square root of 3. So I'm going back to my trig table, and I'm looking at the tangent row, and I find 1 over the square root of 3, which is pi over 6, or 30 degrees, right? So my theta is pi over 6. But since we're looking for, so that's positive 1 over the square root of 3, right? But another angle that has a tangent, which is positive 1 over square root of 3, would also be found in the, what's that? That's in the first quadrant. Would also be found in the third quadrant, because you probably remember that thing with the unit circle, all students take calculus. So everything is positive in the first quadrant, sine, cosine, and tangent. Sine is positive in the second quadrant, which means that tangent is negative in the second quadrant. Tangent is positive in the third quadrant. All right, so pi over 6 is in the first quadrant. So now I need an angle that's got this for a reference angle. And again, it's very important that you understand reference angles in order to solve these equations. So what angle has a reference angle of pi over 6 in the third quadrant? If pi over 6 is the same thing as 30 degrees, then we saying, okay, if this is 180 right here, what's 180 plus 30? 210. So the angle 210 is another solution, but that's in degree measurement. We doing radians. So 210 is going to be 7 pi over 6. 7 pi over 6. Forgive me, I don't do those calculations real quick in my head. Unfortunately. At least not yet. I'm working on it. So 7 pi over 6. So pi over 6 is the first quadrant. 7 pi over 6 is the third quadrant. Those are the two angles that have a positive tangent of 1 over the square root of 3. All right. But what about the negative? What about the angles that have a negative tangent, have a tangent of negative 1 over the square root of 3? Those are in the second and fourth quadrant. Matter of fact, let me do this. First quadrant, second quadrant, third quadrant, fourth quadrant. So first, second, third, fourth. All right. We took care of the first and the third. So now we go to the second and the fourth. So what angle has a reference angle of pi over 6 in the second quadrant? That would be 180 minus 30, which is 150. 150 degrees. You can figure that out by doing 150 times pi over 180. 150 is going to be 5 pi over 6. So that's 5 pi over 6. All right. That's in the second quadrant. 5 pi over 6. All right. Now the fourth quadrant, right? The fourth quadrant also has a tangent, has an angle that has a tangent of negative 1 over the square root of 3. In the fourth quadrant, we would just basically do 360 minus 30, right? If we're dealing with degree measurements, because pi over 6 is 30 degrees. So we keep finding the reference angles. We find the original angle in the first quadrant, then the reference angle in the second quadrant, reference angle in the third quadrant, reference angle in the fourth quadrant. All right. So what's 360 minus 30? That is 330. 330 in radian measure is 11 pi over 6. So these are our 4 solutions for this factor. Because remember, we had 2 factors, right? So these are 4 solutions. So all of our solutions, we have pi over 6, 7 pi over 6, 5 pi over 6, 11 pi over 6, 0 pi and 2 pi. Now 0 and 2 pi technically are the same thing. So I don't know if we have to include both of those. So maybe you could just say pi and 2 pi, or maybe you could just say 0 and pi. I'm not really sure about that. I need to look into that myself, right? But these are our solutions, all right? At a maximum, we have 7 solutions, maybe 6, all right? So again, notice how we used different algebraic routines and processes, and then we applied the information about trigonometry kind of at the end. But most of this is just algebra. It might not look like it, but it's just algebra really, most of it. And then we got to understand some things about the unit circle. All students take calculus, of course. We got to understand some things about reference angles. All right, we had to use that. We got to know what angles have a tangent of 1 over the square root of 3. What angles have a tangent of negative 1 over the square root of 3. We got to know that. So it's a lot of different details and nuances that we have to understand in order to solve for theta in this particular problem. All right, but this is an example. Use this video as a guide, and then go get some practice. You got to practice these problems in order to master this skill. You practice the problems, and then you master the skill. Watch the video, but definitely go get some practice. All right, and I'll catch up with you on the next video. Peace.